So in this session, we'll discuss about the electric charges and how we can charge an object or how a material can be charged. So these are the learning objectives. You should be able to know or identify about electric charges and then the nature of the charge and how an object can be charged. So static electricity, the term static means rest, and electricity refers to when we discuss about the charges. We call that as a static electricity. Now, what is the origin of the charge? What is the beginning? Like why the object is charged? So, as we know, every object, every material is made up of atoms. So, where does the charge come from, or where do the charges are coming from? As we know, all the materials are made up of what? They are made up of atom. An atom consists of neutron, proton, and electron. The central part of the atom, the part which is there at the center of an atom, that is the nucleus, and inside the nucleus we have particles such as neutron and proton. Protons are positively charged, neutron are neutral, no charge, and around the nucleus there is another particle which is revolving and we call them as electron. So the origin of the charge is basically an atom, because atom contain charged particles. When atom contain charged particle, overall, if the number of the proton are equal to number of electron, then what will be the material? That whole material will be neutral. But if the number of the protons are more than number of electrons, like atom contain the ion, the charge contain more proton than electron, then it will be a positive charge. And if the number of the electron are more than number of the proton, then it will be negatively charged. So how an atom can be charged? Because inside the nucleus, neutron and protons are there, so it is difficult to lose these proton and neutron. So only thing what can happen is the number of electron can be changed. Either electron can be added or either the electron is removed. So if electron is added, if another electron is added here, so what will be the charge on this atom? It will turn into negative ion, because it will have more electron than proton. And if the electron is being removed or electron is lost, so number of electron will be less and number of the proton will be more. So the overall, this atom will turn to be a positively charged. So atom can turn into a positive and negative charge is not by losing protons, because protons are there in the nucleus, is either by adding of electron or removal of electron. If there's addition of electron, it will turn into a negative charge, but if it's a removal of electron, it will turn into a positively charged ion. Is it clear the concept why the atom can be charged? In what cases the atom can be charged? So there are two types of charges which are present, or there are two types of charges. There are positive charges and there can be a negative charges in the atom. And the unit of the charge, when we measure the charge, the unit is coulomb. So two things can happen. Number one, if there is an atom, like example, it is having 3 protons, it is having 4 neutrons, and it is having 3 electrons. So overall, because it is having 3 protons and it is having 3 electrons, so what is the net charge? The net charge will be, or resultant charge will be 0, because proton are positive and electrons are negative. But what happens if this atom loses electron? If this electron will go out, So as a result, due to loss of this electron, now what happened? Now it is having more protons. So it is having more protons than electrons. Then as a result, if more proton than electron, what will be the net charge here? So it will turn to a positive charge, a positive ion. So positive charge does not mean it has only protons. It means it is having proton and electron, but more protons are there compared to that of electron. That's why it will turn out to be a positive charge. And opposite can happen. Like example, if you have an atom which is having 8 protons, or say 9 protons are there, and it is having 10 neutrons. Neutrons are neutral, does not contribute to charge of the atom. The first shell, example, it is having 2 electrons, and the second shell, it is having 7 electrons. So what happened for this atom? If it gain electron, like right now it is having 9 protons are there, and when you count the number of electrons, there are 9 electrons as well. So 9 proton and 9 electron, this will be neutral. There will be no net charge. But as a result, what happens if one electron is added? There's an extra electron, so now the protons are less and the electrons are more. So there are more, like, because there are 9 protons, but now it is having 10 electrons. So as a result, when electrons are more, it will never, it won't be a neutral. Because it is having more electrons, so it will turn out to be a negative charge or negative ion. So negative charge does not means only electron. Negative charge also means that ion is having more electron than proton. There are protons, there are positive charges, but the net charge or extra electrons are there. So the net charge is negative. So when it gain electron, the atom turn into a negative ion. When atom loses electron, it turn out to be a positive ion. So atom can turn into ion by loss or gain of electron. Eh, how electron can be lost or how electron can be gained? There are different ways by which we can move the electron. So number one is by friction. Like, what is the concept of the friction? If we rub the two surfaces, like we have two different materials, say object 1 and we have object 2. So we have two different surfaces, object 1 and object 2. What we are doing, we are rubbing them together. So when we rub the two surfaces, one surface rub over the other, there is a friction between the two surfaces because the irregular surfaces are there. When the particles, the surfaces come in contact, so there is a friction. And due to the friction, whenever there is a friction, what it produces, which form of energy? It will produce heat energy. So as a result of the heat energy which is produced because of the friction, this heat energy allow one of the atom to lose electron and another atom to gain electron, because heat is a form of energy. That energy allow the electrons to jump from one surface to another, and it depends on which surface is having a strong bond with electrons. The one which is having a strong bond will not lose, but the one which is loosely bonded electron will jump from one to another. So if the electron jumps from one surface to another, so as object 1 is losing electron, what will be the charge on object 1? So because object 1 is losing electrons, so what will be the charge on object 1? It will be positive. Good. And the object 2 is gaining electrons, so what will be the charge on this object 2? So object 2 will be negatively charged. So one is positive, another one is negative. So whenever object is charged by rubbing one surface over another, what we call this, we call that as charging by friction. So rubbing two surfaces over each other, as a result, it allows the electron to jump. And when these electrons jump, they will travel from one surface to another, and we call that as electrostatic friction, charging by friction. So as you can see, overall, because a substance is a neutral, so initially the cloth is neutral, and perfect glass is also neutral, because like you can see 1 2 3 4 5 positive 5 negative, and this is having 6 positive and 6 negative. So overall they are neutral, but what happened, this is before rubbing, but when we rub them together, now it allow the electron to jump from one surface to another. So in this example, basically what happened, the electron jumped from the perfect rod to the cloth. So if electron jumps from perfect rod to the cloth, because it is losing electron, so what will be the net charge or overall maximum? There will be negative charges, but majority of them are positive. And there are positive charges on the cloth, but majority of them are negative. So this charging occur due to friction or due to rubbing. So we call that as electrostatic friction, or we also say charging by friction. So the perfect rod become positively charged and the cloth become negative. This is because the rod transfer the electron into the cloth. So there are net positive charge on in the rod, and there is net negative charge in the cloth. Same way, if we repeat, like example, when the cloth is rubbed with a polythene rod, so now we have a polythene rod and a cloth. Originally, in the beginning, both are neutral, like 5 positive, 5 negative. Here also 6 positive, 6 negative. So this is neutral. This is also neutral. Both are neutral. But when we rub them together, after rubbing, what happened? This time we observe the electron jumps from cloth to the polythene rod. So as these electron jumps from cloth to a polythene rod, this transfer of the electron, there will be a net positive charge on the cloth and there will be a net negative charge on the polythene rod. So we call that as charging by friction. Is it clear that how we can charge an object by rubbing? So when we rub them together, it produces heat. And that heat allow the electrons to jump from one surface to another. The surface which lose electron will be positively charged, net positive charge or overall positive, and the surface which gain electron, there will be a net negative charge. Then second technique or second method is charging by induction, but this technique is normally used for metals. As we know, metal contain a lattice of a positive ion and the free electrons, delocalized electrons. Like this is a metal. What is the structure of the metal? As we discussed a lot of times, that metal contain a lattice of a positive ion, regular arrangement of the positive ions, and delocalized electrons. Electrons are there which are free to move within these spaces. Now, what happened? Originally, the electrons are evenly distributed, but if I bring, without touching, if I bring a positive charge rod, so when I bring a positive charge rod, we know like charges repel and unlike charges attract each other. So as a result, what happens? These electrons which are originally distributed throughout, uniformly distributed, but as a result these electrons experience attraction. So what it appears, that majority of the electrons shifted towards one side, which is facing the charge rod, and the other side we don't find electrons, or very few electrons are there. So this create a distribution. It appear that majority of the negative charges on the right hand side and the majority of the positive charges or net positive charges on the left hand side. So this distribution of the charge, when we create a distribution of the charge within the metal, what we call this, we call that as a charging by induction. So one method, when we rub the two surfaces, the electron actually transfer from one to another. We call charging by friction. The second technique, in which we bring a charged rod, already charged rod, near the surface, but don't touch it. So this create a distribution of the electrons within the material, and that happen only for metals, because non-metals cannot conduct electricity, so they don't have free charges. Whereas metals, they have a delocalized electron which is distributed due to the positive charge rod, or even it can happen with a negative. But this distribution of the charge, uneven distribute, like the electrons originally they were all around the metal, but now they're shifted more towards the charge rod. So we call that there's a net negative charge on the right hand side and the net positive charge on the left hand side. So we call that as charging by induction. So example, as you can see, if we bring a positive charge rod, so electrons, majority of the electrons are on the left hand side and majority of the positive charges are on the right hand side. Keep in mind, positive charges never move. Why the positive cannot move? Because there is a lattice of the positive ion. So when you have a lattice, it means it's a regular arrangement. So they don't have space to move. So they don't have space to move. Electrons are evenly distributed initially, but when we bring this charge rod close to this, so electron distributed or shifted towards one side. So majority of the electrons are towards one side, so we say negative charge is there on the left hand side and majority of the positive charges on the right hand side. So even though the right positive charges does not move, but as the electrons move out from that this region, so it appears that there is a net positive on the right and there is a net negative on the left, and we call that as charging by induction. So if we bring a positive charge rod on one side, the side which is facing a positive charge rod, that will be negative and opposite will be positive. But opposite will happen if we bring a negative charge rod, then the like charges repel. This time the electrons actually move away from the charge rod and they move away and switch or towards the other side. So we call that as this distribution of the charge which is created due to a charge rod. So we call that as charging by induction. Is it clear, the concept of charging by induction? Any doubt till this point? Then before electric field, what we can do, we can also use the concept, the charging by induction, using the earthing wire. So what is the concept of charging by induction using the earthing wire? Basically, if we allow what is the earthing wire? Earthing wire, or it's also a metal wire which allow the charges to move in and out through the material. So example, you have a metal sphere and you bring negative charge rod. This is a charge rod which we bring, and we have two regions, like example X and Y. What will be the charge on Y? What will be the net charge on Y? The side which is facing a charge rod. The what charge will appear on Y? So the charge appear on Y. You can draw here, you can make on it, or you can make on the surface. Both are correct. So three positive, and keep one thing in mind, that if three positive you are drawing, three negative should be there. Like, well, what is a common mistake from student? If they make like positive, three positive, then they make more negative. That's wrong, because overall metal is neutral right now. So if you are making three positive on the right hand side, then three negative should be there on the left hand side. So number of the charges around, like on the left and the right, when it created a distribution due to a charge dot, should be same. Now what we do, we connect a wire anywhere we can connect. It does not make difference to what happened. So if we connect a metal wire which we call earthing, this is a symbol for earthing. This is a metal wire. So as a result, what happened, because this charge rod is repelling the electron, negative charge here refers to electron, because in the metal the negative charges are electron. Positive ions cannot move, only electrons can move within the metal. So as a result, because these electrons are experiencing the repulsion from the charge rod, so they find space to go out, so they will go out from the earthing. So these electrons will go out from the earthing, uh, from the metal sphere to the earthing. So when these electrons will go out from the metal sphere to the earthing, as a result, what will happen? So as these electrons are being removed, so what will be the charge, net charge left on the sphere, because the electrons are going out, electrons are being removed. So the net charge which is left on this is positive, because the negative charge, majority of the negative charge leave the metal sphere. And if we want to make permanently positive charge, so what we should do, like we don't want these electrons to return back. So first, if we want to make a permanently charge, so first remove the earthing wire. Then first we should remove the earthing wire, and then what we should do, then we'll remove the charge rod. So first earthing wire and then the charge rod. As a result, what happened, once the electrons are being removed, so we'll remove this earthing wire. So this earthing wire is not there. As a result, if it's not there, so electrons cannot return back. And when electrons cannot return back, so this material will have a net positive charge. This is called charging by induction using the earthing wire. And same thing can be done, like example, if we have a metal sphere and we bring, this time we bring a positive charge. So we have a metal sphere and we bring a positive charge rod. So as a result, what happened, one side will be negative and one side will be positive. Now what we do, we connect an earthing wire. As we know, positive charges can never move because of their mass and size. They are in the lattice, so they cannot move. They can only vibrate. So as a result, what happened when we connect, in this case, when we connect an earthing wire, so this time, because earthing is a metal wire, metal also contain electrons. So this time the electrons from the earthing will move towards the metal, and overall what they will do, as mostly electrons will be there, so this whole part will turn out to be negative. So electrons are actually attracted towards the charged rod and the positive charge. So this overall will be negative. And if you want to make a permanently negative charge, so we don't want the electrons to return back. So first what we should do, we should remove the earthing wire, and after that remove the charge rod. So first, whenever you want to make it a permanently charged by induction, first always remove the earthing wire and then the charge rod. Because why we remove the earthing wire? As the earthing wire does not allow the charges to flow back. Is it clear that how an object can be charged by induction using earthing wire? Any doubt till this point? So as you can see here, we have a positive charge rod. It creates a distribution, negative charge on one side and positive on the other. Now if we connect an earthing wire, and we can connect from anywhere, it does not make difference. I can connect from the top, I can connect from the bottom, I can connect from right hand side. So example, if we connect earthing wire here, so what will happen, because this positively charged rod and this positive, so they will attract the electrons. So this time the electrons will go in, and when these electrons will go in, majority of them are electrons now. So overall net charge will be negative. Originally it was neutral, only distribution of the charge was created. But once we connect an earthing wire, it, it also make net positive or net negative depending on the movement of electrons. And opposite happen if we bring a negative charge rod to a metal sphere and connect an earthing wire. So this time what it caused, because this negative charge repel the electrons, so electrons now find a space, so they go out. As these electrons will go out, so majority of them, as these electrons are being removed or they are going out, so majority of them are positive. As a result, as majority of them are positive, so this will be net positive. So it depends on what charge rod we bring closer to a metal sphere. If we bring a positive charge rod, overall if we connect an earthing, it will be negative. If we bring a negative charge rod near to this, so overall at the end it will be positive. And we know if we bring opposite charges, like example, one is positive, another one is negative, so unlike charges will attract each other. Whereas if two identical charges, like charges, positive, positive, or positive and negative, they will repel. Then what is the concept of electric field? Electric field is a region around the charge where a small positive charge can experience force. We call that region as electric field. And how we represent a region, like example, if I have a positive charge and near this positive, I place another positive. So what will happen? We know like charges repel each other. So this positive charge will repel. So that's why whenever we have a positive charge, when we draw the electric field lines, the electric field lines means lines which are showing the field strength and the direction of the field. These are known as electric field lines. The distance between the line shows the strength. Like example, as you can see here, the lines are closer, but when we move away from the chart, the distance between the lines is increasing. So it means at this point, it is strong. whereas this point it is weak electric field. And the direction of the electric field is always a direction in which the positive charge experiences the force. So if we have a negative charge, say a negative charge, and we bring a small positive charge closer, so as a result what happens, this positive charge is attracted. So as this positive charge is attracted, so what is the net or the direction of the electric field? So direction of the electric field is into. So for negative charges it is into, and for positive charges it is out, because the direction of electric field is always a direction in which the positive charge experiences a force. So example, if I have, this is the direction of electric field. So it means on the right hand side you have positive and the left hand side you have negative. If you place a proton here, proton is a positive charge. So which direction proton will move? The positive charges always move in the direction of the electric field. So proton is positive. So where it will move, because the like charges repel and unlike attract, so proton will move towards the right hand side. But if I place an electron here in this field, we place electron. Electron is negative. So it means electron attracted towards the positive charge. So in short, we can say the positive charges moves in the direction of electric field, where negative charges moves opposite to direction of electric field. So whenever you have a positive charge, it will always move in same as the direction of electric field. And when you have a negative charge, it will always move opposite to direction of electric field. And the distance between the field lines shows the strength of the field. So the distance between the field lines shows the strength of the field. Example, if two field lines or field lines are closer, and if field lines are away, they have greater distance between them. So what it shows, which one is stronger field, A or B? Which is strong electric field, A or B? The distance between the field lines shows the strength. If the field lines are closer, stronger. If field lines are away, weaker. So which is stronger electric field here, A or B? So, so when the field lines are closer, it means it is stronger electric field. When field lines are away, it means it is a weaker electric field. So the distance between the field lines is important. That stronger electric field when they are closer, and weaker electric field when they are away. And opposite when we say if there is a proton, so where the proton will move, same as the direction of the field line. If we have electron, it will move in opposite to direction of the field line, because proton is positive and direction of electric field is always from positive to negative. So if we want to draw the electric field pattern, so you have to learn these patterns. The electric field is a region in which the electric charges experience force, and the direction of the field is always in the direction experienced by force experienced by a positive charge. So if field line due to a positive charge, so you will draw the arrow outward. Field line due to a negative charge, you will draw the arrow inward. And if you have two like charges as they repel, so between them there are no field lines. So what does it mean? If there are no field lines, it means there is no force. Like charges, if they are placed in this region, they don't experience any force because there are no field lines, as the two charges try to cancel out each other. And if we have unlike charges, opposite charges, the field lines will be around them, and it is always from positive to negative. Distance between the field lines shows the strength. As you can see, here the field lines are closer, but at this point the field lines have a greater distance. So it means when the lines are closer, it means this is a stronger field, and away from that, it is a weaker field. And if we want to draw the electric field for two charged rods, positive and negative. So if we have a charged rod, like example, one is positive, another one is negative. So field lines are directed out from positive and into negative. Is it clear? The concept of electric field lines. Near the edge it will be curved, but between them it will be a straight line. Any doubt till this point?